Hi, Andreas. Nice to see you. Welcome to our little interview. Let's start with a quick introduction.
Hi Jens, yeah, thanks for having me. Pleasure being here. Shall I introduce myself?
Yes.
All right. So,
Down everyone.
all right. Hello everyone. My name is Andreas Fertig. I work as a trainer and consultant for C++. I like speaking at conferences, and this year I have the pleasure of being at Meeting C++ in November for the first time in person. So I'm really looking forward to this event and delivering a great talk, hopefully.
Yes. And actually, let me bring up your talk. There we go. Actually, thank you, Andreas, for sponsoring also. That's like today is not only a speaker interview, it's also kind of a sponsor interview. Thank you for. So, as Andreas said, he's a speaker, but also a trainer, and so he's also, as you can see here, a book author. He has written 2 books, but we'll be focusing now for the start of the interview on his talk, which is Fast and Small C++ When Efficiency Matters. What's this talk going to be about, Andreas?
Well, I have this one class that I teach a lot of times in the year where it's mostly about writing efficient C++ for several use cases. It's often related to embedded systems, and it's either being fast, so having a good speed there for your code, or leaving a very small memory footprint. And I show various examples in this training class usually, and now I picked some for a talk because I think it's great for a broader audience. And for several things, I look always in the standard library. How are they doing things? And usually they in a smart way. They have similar goals, less memory footprint, being small and efficient and all that stuff. So I started looking into the various string implementations that the different libraries have. So libc++, libstd+C++, MSVC's STL, and they all do it differently. And I think they all have a different focus. And I find that a really interesting example because everybody has the same goal. They even implement the same spec, but they do it in different ways. And I think, I don't really know it for sure, of course, but I think they had a different focus on what they optimize for their standard library. And sharing that and showing how it's done there, it might help in your code making several decisions. There's another part about a standard library where they are trying to be very clever when, for example, it comes to a unique pointer and save bytes there, ROM in the end. And the one part that's also in there, I'm really looking forward to speaking about that for the first time public, is what constexpr can really do for you. I saw others like Jason Turner and myself and a lot of other people struggle showing compelling examples how efficient constexpr can be. And I think I found something which comes from a customer project which illustrates quite nicely what constexpr can really do for your code, being in this case really both fast and small. Yeah, I think that's the cliff notes there.
That sounds interesting. So you mentioned embedded. Is this just like an example, or like do you is this like an embedded talk?
It's not an embedded talk. It's open. It's just that embedded folks usually have a very strong focus on either they're very keen about jitter delays and all that stuff, or they have very constrained systems. But similar things apply to the game industry as well and to other disciplines. So it's not focused on embedded. It's just giving, well, the STL you can see is an overview of how things can be done. The const per part, I think it's always nice to have code that runs fast. So if my phone starts quickly, I'm happy. And well, okay, maybe I should say my computer because that's not a better device then, right? But you can apply them in various yeah scenarios.
It's true. Performance is at the core of C++. So that seems like a very interesting talk. And I see it's in track A, so actually everybody at the conference can see it, and it will be streamed to the audience on the internet. So
cool.
I see you mention C++23 in your talk description. What's your general impression from 23?
So I started looking into my C++20 book and how things changed for the parts I wrote there in C++23. And I think at one point I could save, let's say, 6 pages because certain things got easier in C++23. So for me, I would say it's a great bug fix release maybe to C++20. We added a couple of things that we didn't have time in the 20 time frame. We learned some, maybe mistakes. I would say the C++20 stud is constant evaluated. In C++23 we have a if const eval, and that's the better solution. So this was a learning curve, sadly necessary. And so compared to C++20, I think 23 is a small standard, so not that much to teach or to learn, to digest, but a very good addition to C++20.
And I know it's always like at the conference we have a lot of talks about the new standards, but like how is the reality? How much do you teach still older standards?
Yeah, so the most frequent class usually is C++17. I have a few customers who were already looking into C++20, and there it's interesting because I'm not sure if it's really 50-50, but some of them only wanted the class to give or to get a preview of what they will be able to use in the near future. So, and this is even experience from this year, so 2024. And others, I would say the other 50%, they're already actively using C++20 and they want to get to know it better. Most often it's a structured approach to C++20. But the 70-80% of my classes are C++17, and a few of them are even before C++17. So some customers are still stuck with C++14.
Yeah, I know it's like some long-time projects where you will be on a standard for a very long time. And let's not forget that some embedded standards like AutoSAR are on C++14, and then that's your standard. Let's have a quick look at your book.
Mm-hmm.
You mentioned your C++20 book, so it's linked in your profile from the talk. So are you planning to do an update to 23?
That's a good question, and I'm definitely looking into it. I just need to wrap my head around how I want to do it. So I don't want to start from scratch with 23. I think 23 is not that big, at least for the things I usually talk and care about. And C++, it's programming with C++20 was written as you cannot necessarily start C++ with that, but you don't need prior knowledge from 17 or 14. So C++ 11 is the base standard. I assume there are features I use that are from 17, for example. I introduced them briefly. And I think about simply updating this book to 23. As I said, I obviously experimented with it a little, and I can in one chapter save 6 pages, and others will be added for new features. So the goal would be that the book remains roughly at the same page size. But I'm trying to figure out whether this is really then worth it or not. So I haven't decided yet.
What's the part where you can save 6 pages? Is it like coroutines getting easier, or?
No, sadly not. I think it was std format, actually.
Okay.
This is one of the changes that makes this book a very tough one, because I think we did a very unusual thing there. We updated the specification after C++20 was released. So we did a couple of, we call this DRs, defect reports, that apply retroactively to C++20, and they break things. So we really changed things, and the rationale at the time was there is no implementation out there. So I think it was maybe only Microsoft who had an implementation, and that this was deemed safe enough. GCC and llvm clang, they didn't implement std format at the time, so there was no users practically. But there were already people having written books. And so this now bites me that we changed things in C++23 then itself, changed a couple of things. So things get different, get a little easier. And sadly, some things turned out to be no longer as true as they are per C++20 standard, but your compilers usually only implement C++23 for that feature. So that's the part I remember that made a lot of difference. And there we can, I would now be able to replace all the couts with std print in C++23, and that's, I think, a very nice change.
Yeah, it's much more readable, definitely. Yeah. But it's also a lot of editing. So. Yeah. One could probably write a C++ program to edit the code.
I asked ChatGPT.
I don't know. That's a good idea. So you have experience with ChatGPT and code?
No, not really. I try to stay away from it, but I do have, of course, some encounters with it, and sometimes it's amazing what it produces. Really, either might be for descriptions. So summarize me some part of C++, like what are templates, and also if you ask it to generate code for you. But often that's really good, but I've at least one example I have, and it's even published by I don't remember the source, but it's they market it, some AI company, and the code has undefined behavior. So essentially, it takes a std string, I think, creates a string view out of it, and does some bogus things and returns in the end something that will not outlive the function. So the code looks good. The code looks neat. It's just 2 lines or so, but if you don't know the language good enough, you copy that and you bring trouble to yourself. So this is, This is my experience so far with ChatGPT, but I don't use it. More than that, I got requests whether I would teach or use it in my classes, more Copilot than as a assistive tool for programming. I had one attendee just the other week. In my classes, I do exercises such that people can apply what we just talked about and see how it really feels, and questions arise. And one of them said, well, we couldn't really figure out how to do this, so we asked ChatGPT, and then we looked into your solution, and it was pretty close. So that was one word there. I have to change my exercises.
I think one of the problems with AI in general is that it's very confident also when it's wrong, and it doesn't understand why it's wrong. And my personal experience with ChatGPT, etc., is very minimal. But for this year, I had, like, for the first time that we had actually AI generated submissions for the conference, where you clearly see that. And some people seem to just copy it and not really read it, and that's not really, like, good for your submission.
Yes, okay. A new danger then, so to speak. Yeah. Okay.
And it's like even hard to, like, I didn't have a rule in place to say no such submission, but on the other hand, I see that there's other submissions which get very close to it. So, and I don't know, do those people also use ChatGPT? Do I have to ban a good speaker who submits a good talk? So I think ultimately the voting will decide who gets to speak.
Yeah, I like the voting you do. I think that gives a very good indicator which talk to really then have for the conference. And for ChatGPT, it might be able to write my abstract, but I believe the talk I still have to deliver myself. So I need to know what I wrote in the abstract, right? So hopefully it works out.
So what things are you currently up to with C++?
So just today I tried to follow the llvm clang upcoming 19 release to update C++ Insights. I was kind of hoping I can do this before I fly to CVP Con, but it looks like they added another release candidate, and I'm not sure it will happen before I fly out for CVP Con. So yeah, I was trying to stay as close as possible there, but maybe then October or so when I find the time to update to C++ to Clang 19 then.
Sounds like a good plan. Yeah, unfortunately, we're not making it at CPP Con. Do you give the same talk at CPP Con, or?
Yes. So Meeting C++ has the advantage that I have a test run at CVP Con for this talk. It will be the first time I deliver that, so there will be some fixes. Usually there are whatever it might be, typos on the slides or trimming the examples a bit in a more compelling way. I'm not sure. And I have the pleasure to actually be one of the few people who give 2 talks at CVP Con. They limit it to be 1 per speaker, which I think makes sense. But I have another talk in the back to basic track. And I agree with their decision that it's a little bit limiting for me as a trainer to only talk about the basic stuff when I have other things to talk about. So it was always then deciding which do you want to do, and this time they said, okay, for this special track we lift the restriction, so you can have 1 in the back to basics and 1 in the main track if that one gets accepted, of course. And I have another one there. But this is the first one, and I'm looking really forward to that one, and of course to the Meeting C++ version.
Yep. that's I think today it's like 70 days, or it's like around 70 days away. And I've heard you give a training at CVP Con.
Yes, I do. I have a post-conference workshop there, 2 days, and it's modern C++ when efficiency matters. So it's the longer version, you can say, of the talk. A little bit different topics maybe, and this I teach this time in person. So this will also the first time doing that in Aurora. Yeah, we'll see how that one goes.
Okay, I see we have a question from the audience.
Sure. Yes.
Hello, Andreas. You've mentioned most of the classes are for C++ 17. Why do you think it is this way? Does it mean people who are looking for C++ developer positions should master in C++ 17 before digging into C++ 20 features?
Yeah, that's a good question. So the disclaimer, first being said, that's my personal experience and my thoughts on that question. There are multiple things why I see people or companies still, let's say, still using C++ 17. One is that they have a tool chain environment which they cannot change that easily. If you go to especially embedded devices, if you look at automotive, if you look at the medical industry and a couple of other things, they cannot easily change the compiler because they have to write tons of papers where all the compiler versions are locked. They have to prove that a new compiler doesn't change anything and all tests are still passing. So you don't want C++ 20 in your car, but the brakes stop working because of one little change in the compiler, right? So this is one thing. Some of the projects, even outside of embedded, are planned for a longer time, and switching the compiler simply causes friction. So sometimes they don't want to spend essentially resources in terms of money or people on that. And the other thing I noticed is that I would say because C++ 20 is so huge as a release, I would say it's even bigger than C++ 11, maybe. There are so many new features in, and the compilers still haven't implemented them in full. So modules are still lagging. Even that GCC and Clang have caught up. Microsoft has the only implementation currently that I would really, let's say, start trusting. And the others are still officially, I think I haven't tracked it this week, but they're still in more or less a beta testing state. And my experience with C++ 11, my personal experience was if you switch to a compiler that claims to support a standard but only implements a portion of it, tracking errors can be really difficult. So my personal experience there was I had aggregate initialization or uniform initialization, and the compiler said it had C++ 11 on, but it didn't implement that one change. And it simply gave me a very long compile error and took me more than an hour, I guess, to figure out that it was not my fault. I did everything right. It was just a compiler, despite saying it's C++ 11, not supporting it. And this is, I think this is the maybe bigger obstacle there, that the standard was so huge that compiler vendors still doing implementations. I'm not sure, but I believe I'm correct that, for example, Clang 18 did not fully implement std format. I think they are on a very good way. They are very close to have everything in there, but I think they were missing a few pieces. And the question is this a piece that you require? And then you cannot switch, essentially. And I think this is the other maybe bigger roadblock for the people who are more willing to upgrade. And of course, you have people who say, hey, I need the best for my software, the fastest and the smallest and whatsoever, and we upgrade. So I have customers there on C++23, which ironically is not even an official standard, because I think ISO still has to stamp it to make it an official ISO standard, despite that we have released it in March last year or so. So yeah, and you have compilers that can do C++23, and for what I've seen, they are much better implementing C++23 than better means faster than C++20 features, because there's essentially less to do. Yeah, that would be my answer to that. Very long one, maybe.
I think that a big part of it is that the management doesn't understand the advantages. That selling standards upgrades is really, really hard because the projects are large. There's a lot of code to be covered. And don't underestimate how many people do not have tests. So for them, it will be like, you need to like split your code base and have things tried out and see if things break. But they don't like have like a test coverage, which is like all good. We upgraded the standard and it's fine. That's not their reality.
Yes, and since you mentioned breakage, it's sadly true that C++20 can break some things coming from 17. So especially the spaceship operator, I know from personal experience, caused some friction there, and this is also not necessarily something you expect or you want to pay for, and you might not see the end of it at the beginning, right? When you start and it doesn't compile. So yeah.
That's true. Let me quickly plug a talk, because you talked about modules, and actually the top voted talk we had is about modules. It's by Andreas Weiss.
Yeah, the other Andreas.
Started today because modules have been one of the most highly anticipated features of C++20. I think that's an understatement. Unfortunately, it was also the language feature that took the longest to become widely available for developers to use. This year, for the first time, we see broad support for the feature in all major compilers and mainstream build system support through CMake. The goal of this talk is to provide you with all the basic knowledge to allow you getting started with C++20 modules today. And I think that's true. Like, we are in this time frame where we're basically just having the technology available and we're getting started with modules.
Yeah, so I look forward to Andreas' talk. I think that
yeah,
will be a great one. And yeah, as he mentions, right, I forgot the build infrastructure. This is maybe one of the big hurdles that some people aren't aware of. It's not just having a C++ compiler that supports modules. You also need the build infrastructure. So that means you have to upgrade CMake, make Ninja and all the tools you're using. And I think only CMake currently really does support modules, but I might be wrong there.
So we are starting to be able to have like full support for modules out in the toolchain. And I don't know how mature the module implementations of GCC and Clang are. And I guess right now, maybe it's for early adopters if you're not on Microsoft. But yeah, looking forward to his talk and generally to meeting C++. Thank you, Andreas. And with that, I'm going to end the interview. Any last words?
Well, thanks for having you. To all the YouTube audience, LinkedIn audience, if you haven't booked your ticket for meeting C++, do it. You can join online or in person, and I think it will be a very great experience either way. So thanks for having me. And hopefully, Jens, I will see you definitely at meeting C++, but maybe you as well.